This video is a new binomial factoring pattern that is very much like the difference of two squares. Starting now, it's the sum and difference of cubes. Okay, while we learn to factor using the sum and difference cubes pattern, be ready to look for our greatest common factor. You should also be able to write a polynomial as a cube. So if this math sentence is confusing to you, 8x to the third is equal to the quantity 2x to the third power. You need to go back and review the skill before we get started. So the sum and difference of cube methods, they're used to factor binomials whose terms are cubes. Remember what a cube is? It's just a number that's result of multiplying something by itself 3 times. So first we have a sum formula, and then we have a difference formula. If you take a moment and look at them, they're very, very similar. The only difference is that they have different positive and negative signs. Now to remember those signs, we can use an acronym called SOAP. SOAP stands for same, opposite, always positive. Okay, so my first two signs will be the same, then it will be the opposite, and then always positive. We can use this pattern if 3 things are satisfied. First, it has to be a binomial, which means it's 2 terms. Second, it must be a sum or a difference. And third, it has to be 2 cubes. So it's going to look like cube plus cube or cube minus cube. Let's factor t to the third minus 27. As always, we check for our GCF, which we don't have. I'm going to quickly check my requirements. This is a binomial because it has 2 terms, and it's a difference. Can it be written as 2 cubes? 27 is 3 to the third. So we're going to rewrite everything as a perfect cube. We did this as part of our requirement step. Now we need to choose the right formula. So I look here, that is a subtraction sign, so I'm going to use a difference formula, which is my second formula in the top right. Then I like to put the form out there and then fill it in. So t goes in the front, 3 is my second spot, then t squared, then 3 times t, then 3 squared. My final step is to determine if I need to simplify anything with exponents, and I do. That 3 squared needs to become a 9, and I'm finished. Let's factor 2n to the 9th plus 16. First, I see a GCF of 2, so I'm going to factor that out. I'm going to quickly check my requirements in the parentheses. This is a binomial and a sum. It can be written as n cubed cubed and 2 cubed. So let's rewrite the expression in our parentheses. Now let's choose our formula. We have an addition sign, so we should use the sum formula. We can now populate the formula, keeping the 2 outside of the parentheses. N cubed first, then 2, then n cubed squared, then 2 times n cubed, and finally 2 squared. After everything is populated, we're going to simplify any exponents, and I see that I need to simplify n to the third. That should become 6, and 2 squared should be 4. Okay, 8 to the third plus 6. So right away I say I don't have a common factor. Take a close look at this one before we start. Do you see anything? Okay, it's a binomial, and it is a sum, but guess what? 6 is not a perfect cube, so we cannot use this formula. And I know what you're thinking. You're thinking 2 times 3 is 6, so 2 to the third is 6. That is wrong. 2 to the third is 8, and we cannot use our formula here. In our final example, we're asked to factor 64n to the 18th minus 125z to the 12th. I don't have a common factor, so I'll quickly check my requirements. It's a binomial, a difference, and the 2 terms are cubes. Rewriting my cubes gives me 4n to the 6th cubed minus 5z to the 4th cubed. I'm sorry, that is such a tongue twister. I'm ready to choose my formula. I see that this is a difference, so I'm going to use my second formula. I'll make some space to plug everything in and start populating. Hopefully you're getting the same answers. And then finally, we're simplifying. My 4n 6 to the second needs to become 4n 16n to the 12th. Then I have 20n to the 6th z to the 4th, and finally 25z to the 8th. Okay, so today we learned our last binomial factoring formula, or pattern, which is the sum and the difference of cubes. Remember, we have to rewrite both terms as cubes, we have to apply the correct formula, and then we need to simplify any terms with exponents. Look at how many factoring methods you guys have learned. Stay tuned for our next factoring method, which is using the AC method. It's a very elegant formula, and it's my favorite.